All right, so today I just want to take you through the final question of the May 2025 paper. You may have seen this before. I hope it's useful for you. It was a slightly different sequence in terms of the second part and the justification. So you'll see what I mean by that when we get to it. So here we, of course, have our structure. So a structure is created using cubes. In this question, you will investigate the number of cubes in the structures. So interact with the stage control to reveal the structure and number of cubes C. So we've got stage 1, which you can see here is made of 5 cubes. Stage 2 is 9. Stage 3 is 13. And then stage 4 is 17 cubes in total. Okay, so there's your 4 stages. Now, question 8A asks you to construct stage 5 by completing the structure on the canvas. Okay, so I'm just actually going to go straight to the next question first of all, and then we'll come back to this. Okay, so I want to, of course, like always, complete my table. And I'm just going to, because I can see the numbers easily here and it saves me going back to the stages, I can just calculate exactly what's happening here. And then I can work out, of course, how many cubes I need to have in stage 5 and so on. Okay, so I can see that we are adding 4 each time. So it is a linear sequence or an arithmetic sequence. So I know that stage 5 would have 21 cubes, and then stage 6 would be 25 cubes. Okay, so on that, I can go back to this question. I want to, of course, calculate how many cubes do we have so far. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, and then 19. Okay, so I just worked out that we need 21 cubes in total. So you may have noticed that here has 5. Okay, this sort of leg also has 5, but we're missing 2 at the front. Okay, so you, of course, would drag and drop, but you would need to place one here, and you would need to place one here also. Okay, just to extend basically at the end here. So I'll just sketch that on to show you what it should look like roughly. Okay, and you would add those 2 cubes at the ends. Okay, so you'd have 21 cubes in total. Okay, so back to the sort of usual part of the question that we always expect to get. 8C wants us to describe in words 2 patterns in the table for the number of cubes. So it is a linear sequence. Okay, the common difference is 4. Okay, you can also word that as the sequence increases. So the sequence increases by 4 each stage. Okay, but that is just the same thing as saying that the common difference is 4. Okay, but type of sequence and what is happening, those are your things that you want to make sure you say. Okay, then of course we are asked to find a rule for C in terms of n. Okay, so just to show you how I do this, I'm going to write out my sequence. So we have 5, 9, 13, 17, 21, 25. Okay, we've already said that this goes up by 4 each time. So we are adding 4. Okay, so that's going to tell me that for this sequence, I know for sure that C is equal to 4n, but then I also need to check, well, what would come before 5? Okay, well, if I subtract 4 off 5, I would get 1, just positive 1. So my rule is 4n plus 1. Okay, then we are asked to verify. So remember that to verify, you can use the 2 stage numbers for which you predicted values. Okay, so in the table, we filled in for stage 5 and 6. So you can use any one of those. Now, I do have a habit of always using both of them, but you actually will still get the marks if you just use one. Okay, so in terms of using correct notation as well, we want to write C and then little 5 is equal to 4 lots of 5 plus 1. So all I'm doing here is substituting 5 in as my n value. Okay, so C of 5 is equal to 21. And then you must say that this matches my prediction. So this matches my prediction. My rule is verified. Okay, you can repeat the process with 6, but you don't have to for the marks. Okay, so 1 is enough. Okay, moving on. So AF, it says you will now investigate the total number of cubes in a new structure. So interact with the stage control to reveal the structure and number of cubes. So we've got stage 1, the volume is 6. Stage 2, the volume is 13. Stage 3, the volume is equal to 22. And then stage 4, the volume is equal to 33. So it says write down the number of cubes that will be added to stage 4 to construct stage 5. So what I would do here is basically the volume numbers that obviously create this new sequence. I would write out, so 6, 13, 22. So 6, 13, 22, 33. And of course, I want to work out, well, what are we going up by each time? Okay, so 6 plus 7 is 13. 13 plus 9 is 22. 22 plus 11 is 33. So then back to the question, it wants us to write down the number of cubes that will be added to stage 4 to construct stage 5. So we're going to need to add 13, aren't we, to get to the next stage? So your answer for this question is 13 cubes. Okay. And of course, if you want, you can, work out what stage 5 is going to be there. So it's going to be 46. I'm sure you're going to use this in the next part of the question. Okay, so then on to the big part. So the 20 marker, we want to investigate the values in the table to find a relationship for the number of cubes V in terms of n. In your answer, you should communicate the following in an organized and coherent manner. So to do this in an organized and coherent manner, please remember to just follow the bullet points. They will help you to structure your answer. Okay, so the first thing we're going to do is predict more values and record these in the table. So let's do that first. We said 46 was going to be next. So that was adding 13. Okay, so then I know the next one I'm going to need to add 15. Okay, and that's just following that previous pattern that we've already identified. So 46 plus 15 would give me 61. So then for stage 7, we're going to need to add 17. So that would be 78. Okay, so that's the first part done. And we can tick that off. We predicted more values. So now what we need to do is describe in words 2 patterns in the table for the number of cubes V. So you could write that V forms a quadratic sequence. Okay, the difference between each stage increases by 2 each time. Okay, and I would give the example of this particular question and what's actually happening. So, for example, the first difference between 6 and 13 was plus 7, then plus 9, then plus 11, and so on. So I'd write this out. So plus 7, plus 9, plus 11, plus 13, and then you can just ... Okay, and that would be enough for you to get your 2 patterns. Okay, on to the next part. It wants us to write down in simplest form a general rule for V in terms of n. Okay, so depending on your method and what works for you, I always use the table method So my sequence goes at the top. So I have 6, 13, 22, 33. Okay, I know from my first difference that they are increasing by 2 each time. Okay, so that means it's going to be 1n squared because we half the second difference. So half second difference. I'll just make a note of that to remind us. So that means I've got, well, sorry, I want the n squared sequence. Okay, so remember to create this sequence, you are substituting in the position. Okay, so position 1, n is 1. Position 2, n is 2. Position 3, n is equal to 3, and so on. Okay, and all you're doing is substituting those values in to n squared. So 1 squared would be 1. 2 squared is 4. 3 squared is 9. And 4 squared is 16. And of course, we want to work out what the difference is. So we subtract. So 6 take away 1 leaves me with 5. 13 take away 4 leaves me with 9. 22 take away 9 leaves me with 13. And then 33 subtract 16 leaves me with 17. Okay, at this point, you would want to notice that that difference is not the same each time. Okay, so what that tells me is that this forms a linear sequence. So it's going to have a linear component, and I need to find the rule of this part. Okay, so what's happening between each of these terms? We are adding 4. Okay, and the one before would have been 1. Okay, so to put all of this together, our sequence for V is going to be equal to n squared plus 4n plus 1. Okay, so that's your general rule. Okay, so that's the next bit ticked off. Okay, next part wants us to test and verify our general rule. So really important in your answer that you make it clear what you're doing. So I would, go as far as to give yourself a subheading in your answer. You can use, the underline tool to underline, etc. Remember, for testing, you can use m values less than or equal to 4. So let me highlight that so it's nice and clear. So we can use any of these values here. And then for verify, we're going to use m values greater than or equal to 5. So like in the first part of the question, you will use the values where you made predictions. Okay, so let's do that. We're going to test. I'm going to use 1, so V1, which would be equal to 1 squared plus 4 lots of 1 plus 1. That would give me a total of 1 plus 4 plus 1, which is 6. You, of course, want to check back, make sure that matches your sequence. It does. So this matches the table or the sequence. It doesn't matter at that with regards to table or sequence. This matches the table. I'm going to repeat once more. So V2. So 2 squared plus 4 lots of 2 plus 1. So V2 is equal to 4 plus 8. So 13. Again, this matches the table. And at this point, you want to say that your rule is tested. So my rule is tested. Okay, and that will get you all of your testing marks. You want to repeat the process for verify using m values of 5 or more. So if we will use 5, so 5 squared plus 4 lots of 5 plus 1. and that is going to give us 46. Okay, this matches my prediction this time. This matches my prediction. I'm going to repeat once more. Now, remember, you don't have to do this. Okay, you do only get the mark for the first one. I'm just doing it so that you can really understand the process of what we're doing. Okay, so 6 squared plus 4 lots of 6 plus 1, that would give us 61. Again, this matches my prediction. And then you can complete your verification with your final statement of my rule is verified. So my rule is verified. Okay, so let's just go back to our bullet points. We have done everything except for our justification. Okay, and to do this, you again want to label it clearly. So justification. And what you need to do, my advice here is you need to find the link between the first part of the question and the second part of the question. So our first sequence was a linear sequence and it followed this. So let me just copy this and move this down. Okay, so put that there. Okay, so that was our first sequence for C, and our rule for C was 4n plus 1. Okay, here we have our volume sequence. So let me copy that. Okay, and what we want to notice here really is the difference between them. Okay, and how we get from one to the other. Okay, so if you look at stage 1 for the number of cubes in C versus V, you can see that we've gone from 5 to 6 cubes. Okay, so we've added 1. For the next stage, we went from 9 cubes to 13. Okay, so we added 4. Then we went from 13 to 22. Okay, so we added 9. And then 17 to 33, we added 16. Okay, if we keep going, 21 to 61. It's not 61, 46, sorry. We added 25, and then from 25 to 61, we added 36. Now, what you would hopefully notice at this point is that the difference between them, well, these are the square numbers, okay? 1 squared, 2 squared, 3 squared, 4 squared. So what we are doing is we are taking the values of C and we are adding the square numbers. Okay, and that gives us our volume. Now, of course, we need to put all of that together. Okay, so our formula for C was 4n plus 1. Okay, and if we created a sequence, a rule for the sequence of square numbers, then it would just be n squared, wouldn't it? Okay, which equals V. Now, of course, you can see if you rearrange that, that is the rule that we got in the first place. Okay, so for the justification of this question, honestly, it was a little bit abstract compared to previous examples that we've had on earlier past papers. Not as easy to find the link, to be completely honest. You just have to look, well, what is actually happening? Okay, we're taking C and we're adding the square numbers. Okay, so in terms of the justification and making sure that you get all of the marks. You, of course, need to, first of all, make it very clear that this is a justification. You definitely want to write down what your sort of thought process is. So here we know that C plus the square numbers is equal to V. Okay, and then all we're doing is substituting in the formulas that we found for those respective parts. Okay, you would want to finish this like with testing and verifying to say, hence my rule is justified, or my rule is justified. Okay, but you would definitely want to make sure that you also make comment that the difference between them, okay, is the increasing of square numbers, okay? So they want some sort of reference to this down here in the answer. So you could even say, let's say, let me move this bit down a little bit. So you could say, so +1, +4, +9, +16 is being added to the number of cubes. Okay, and that would make it complete. But that is that, and that would get you the full 20 marks. But like I said, it's just a bit of a weird justification because usually we have a formula to kind of link it all together with. But this particular example, we didn't have that. So you just purely needed to work out the difference between the two shapes, okay? And use that to justify this time, okay? So anyway, that does bring us to the end of this. I hope that was helpful. Do let me know if you've got any questions.